Hello and welcome to the video tutorial series of CloudStack best practices. In this video tutorial, we will be showing how to create an instance with a larger disk size than the parent template. This also includes resizing the root disk inside the instance, which is non-LVM based. There will be a slightly different procedure for disks which use LVM, which we will be discussing in another video tutorial. In this video tutorial, we are using Apache CloudStack 4.9 and the template was created using CentOS7. We will be practically showing how we can do this, so let's get started. Let's have a look at the template that we will be using. This is the CentOS7 template, and it contains a root disk which is 20 GB. We will be creating a new instance using this template, while we will be setting the root disk size to be 50 GB over here, and we will select the correct template. Click next. We will select compute offering. We will be using two CPUs, 1200 MHz and 8 GB RAM. We don't need any additional volume, disk volume, so we will not be using any disk offering. We will not use any affinity. We will select the correct network, and since we are not using any SSH keys, we will give this instance a name, CentOS7, let's say Resize. Let's launch the VM. This will take a moment to launch. Alright, the instance has been launched and we have been given a random password. We will connect to this instance via SSH, and we will be setting SNAT to this instance so that we can SSH from outside. Let's have a look at the specs of this instance. As we can see that it has been given 2 CPU cores, 1200 MHz each, and 8 GB RAM. And if we look at the volumes for this instance, this is the root disk volume, and which is 50 GB. So CloudStack has provided this instance the correct size of disk. However, we need to expand the partition inside this instance and also create extend the file system on that partition. So let's log into this instance over SSH. So let's log into the instance. We can resize the window size so we can have a better visibility. We already created this user on this instance while creating the template. So let's get elevated privileges. Alright, let's have a look at the disk size. Let's do df-h. As we can see that the root disk has a 19 GB size, which is smaller than the actual disk size which was provided to this VM. This is actually the size of the template which was used to create this instance. Let's do fdisk-l so we can see the total disk size. As you can see that physical disk has been assigned, which is 53.7 GB, but the partitions are using that smaller size. So what we need to do is we need to recreate this partition. This is the second partition, and which needs to use the whole available free space. One more thing that we need to keep in mind here is that we need to know the file system on the partitions, because that is required so that we can use the correct utility to resize the file system. If this is an XFS file system, then we need to use the XFS GrowFS utility, and if this is an ext4 file system, we can use this Resize 2FS utility. So we can have a look at the FS tab file to see that what kind of file system is there. As we can see that the root partition has XFS file system, also the boot partition. So let's look at it again. This is the XFS file system, so we need to run the correct utility, which is XFS_GrowFS for XFS kind of file systems. First of all, let's expand the partition. And the disk is fdisk. The command is fdisk -l. This will show the available physical disks. As we can see, there is only a single disk, x/dev/vda. We need to run fdisk on this device, dev vda. We can print the partition table by running p command or print command. As we can see that there are two partitions. We need to delete this partition and recreate the same partition again. We can get help by typing help or m, which is the same thing. So we want to delete a partition, which is partition number 2, and we press 2 or enter, same thing. We can print the partition table again, and now we can see that there is only a single partition. So we need to recreate the partition by typing n, which is for new partition, and this is we will be setting it as a primary partition. So we will press P and the partition number, which is 2, because first partition is already there, and this will be the second partition, and this is the starting sector. By default it will start after the point where this first partition ends. So let's use the default settings, and the default value is to use all the free space available on the disk. So we will use the default settings, and now let's see the partitions again. Now that the partition has been created, we need to make the changes permanent. We need to press W so that the changes are created, and we exit from the fdisk utility. There is a warning message which shows that rereading the partition table failed with error 16, device or resource busy. The kernel still uses the old table. The new table will be used at the next reboot after you run the partprop or kpart utility. So basically what happens is that we had taken a risk over here that we were using a partition which was in use, which was the root disk on the system, of course. And it is recommended that in production environment we we use the rescue CD for CentOS and boot from that rescue CD, and then we perform these actions. However, this is a test environment and we are still on the safe side. We have not damaged any file system. What we need to do is we need to create a file so that the FSCK is run, FSCK file system check is run when this system reboots. So let's create a file, force FSCK touch force FSCK. This should be under root. So this will ensure that the FSCK utility is run on this disk partition while the system is rebooting, or at the boot or the reboot time. So basically what happens is that there is a file called etc.rc.sysinit. This is in fact this is on some CentOS system. Traditionally, the system used to have a file called rc.sysinit, which was responsible for running this FSCK check. But the latest distros, the CentOS distros, are using systemd instead. So systemd will make sure that if this force FSCK is available, it will run a file system check on the system. So let's reboot the instance, and then we will expand the file system. Okay, now that the system has rebooted, let's log in again. Provide the password, and we get the elevated privileges. And then we do df-h again. Still we can see that the file system size is 19 GB. So what we need to do is we need to run the XFS utility, XFS underscore growfs. This will grow the file system. We can run the mount point on which we need to run this. This is devvda2. So we run this, and it has completed successfully. So now we can run df-h again to see that the file system has been expanded, and now we can see that the disk size is 50 GB, which was the desired size. Thank you for watching this video. I hope that you have gained something out of this, and we will try to come back with new tutorials and best practices for CloudStack.